Let's review half-life. The half-life of a radioactive isotope is the time it takes for one half of the sample to decay into something else. That is, it is the time needed for one half of a sample of radioactive atoms to change into a different type of atom. Sometimes this different type of atom is itself radioactive, other times it's stable. During decay, mass is conserved. Parent atoms are simply converted into daughter atoms. If you have 600 grams of a radioactive isotope, what mass of radioactive isotope remains after 4 half-lives? And what mass of stable isotope is present after 4 half-lives? So we start with 600 grams of radioactive isotope. In one half-life, that amount of radioactive isotope will drop to half, 300. After a second half-life has passed, the amount of that will have dropped to half. After a third half-life, that will have dropped to half, and after a fourth half-life, that will have dropped to half. That's how much radioactive isotope remains after 4 half-lives. Now, what about the second question? What mass of stable isotope is present? Well, the total mass stays the same. So 37.5 grams are still that radioactive isotope that we started with. The rest, in this case 562.5 grams, is the other isotope. You can see that the mass has stayed the same. Let's try this one. Molybdenum-99 has a half-life of 2.79 days. How much of a 16.8 milligram sample of molybdenum-99 is left after 8.37 days? So the first thing we're going to do here is we're going to figure out that we're undergoing decay over a time period of 3 half-lives. Each half-life takes 2.79 days, and so that would be 3 half-lives for 8.37 days. So the question now becomes, how much of this sample is left after 3 half-lives? So we start with 16.80 milligrams of molybdenum-99. After 1 half-life, we have only half that much. After a second half-life, only half of that remains. And after a third half-life, only half of that remains. I deliberately chose these numbers on purpose because I'm hoping that you could cut these numbers in half in your head. 16.8 cut in half would be 8.4. Cut that in half, 4.2, cut that in half, 2.1. That mass right there is the amount of radioactive molybdenum-99. The rest of it, namely 14.70 milligrams, is now stable material, or is the other isotope. Again, the total mass is conserved. So what's happening here you can kind of see on this graph. The amount of molybdenum-99 is dropping, and the amount of what we call the daughter isotope is increasing like so. Whenever you do half-life calculations, you cut in half, cut in half, cut in half, cut in half, and the total mass stays the same.